dioxide levels have been rising in the atmosphere, and over that same period of time, you can see surface temperatures have been going up as well. Now, here's kind of a little ooly. The latest data that I was able to find shows it in just the last 2 years. Look over here. Let's see. It's hard for me to. I can't see the little pointer thing. You can see the just shoots up right at the end of that graph. The temperature just shoots straight up. It's gone up more 0.2 of a degree Celsius just since 2013. So we've already used up. Remember the COP21? They want to keep the temperature rise to 1.5 degrees C, optimistically. You're familiar with that?
Yeah.
Well, we've already used up 0.2 of a degree C of the remaining 1/2 degree margin. We've only got 0.3 of a degree Celsius left before we're even exceeding the COP21. And what do you suppose the odds are staying within that limit? To understand global warming phenomenon, consider a pot of water on the stove. Imagine you get a pot, fill it with ice, put it on the stove, and turn the fire on under the pot. What's going to happen? What do you suppose? Ice is going to melt, of course. And if you turn the fire up higher, it's going to melt faster. Exactly. So, I mean, this is really clear. I mean, nobody can fool you about what it is. You don't need a physicist to explain it to you. And from a branch of engineering called heat transfer, we know that if we know how much ice we have in the pot, and we know the rate at which we're adding thermal energy to the ice, it's a very simple matter, just using simple arithmetic to calculate how fast that ice will melt. Well, the global warming problem is the same. The only difference is the size of the numbers, how many zeros we're talking about. The arithmetic is the same. We know how much ice there is on the planet, 5.7 million cubic miles. We also know the rate at which excess thermal energy is being added to the surface. As of 2005, it was 0.85 watts per square meter. It's gone up since then. It may not seem like a lot. When you multiply that over the entire half of the planet, then you get an idea. It could be a big number. It is a big number. And that's the fire on the stove. So we can, just using this very simple process, and just using simple arithmetic, aided by the use of an Excel spreadsheet, we can easily determine or estimate how soon we're going to gain enough thermal energy to melt all the ice on the planet. And that's what this figure is here. On the bottom, it shows the years since 1800. The vertical axis is millions of quads of excess energy required to melt. And that first little gray zone on the bottom, that's how much thermal energy has to accumulate to melt all the ice in the Arctic. And the top of that second gray zone is enough energy to melt all the ice on the planet. That solid line is the actual curve as it's occurred so far since the 1800s. You can see we're more than halfway to getting to the point where we're going to have an ice-free Arctic. And if we keep going the way we are, it says circa 2050. It could be earlier than that. It could be 2041. It could be even earlier than that. But that's the point that I call the point of no return.
Where is it? Can you point to it on there?
Yeah. Right here. That's what I call the point of no return. That's the point where we've accumulated enough energy, surface energy, energy on the surface to melt all the ice in the Arctic. Okay. Now that's just based on that curve. It could actually happen. That's an estimate. It could actually happen earlier than that. They're finding, in fact, that it is proceeding more quickly than that. We'll talk about that a little bit. And if we don't get off the fossil fuel track, this is just simple numbers that we will, by the middle of next century, accumulate enough energy on the surface to melt all the ice on the planet, including the Antarctic.
So the first one is all the ice in the Arctic, and the second one is all the ice on the planet.
Correct. Okay.
And I guess my question as a biologist is why do you consider melting, I don't know, all the ice on the planet or in the Arctic as the point of no return? Because there's a lot of other things going on, like droughts, and droughts is, yeah. And the Atlantic, the current in the Atlantic that carries warm water up, and then it sinks, and
The conveyor belt.
that would, the conveyor belt,
Yeah.
that would, I think that would turn off a lot sooner than all the ice being melted. I mean,
Well, yeah, I can easy to get caught in a sidebar here.
yeah.
There are a lot of factors that will speed up, slow down, move energy around the surface.
Mhm.
Ocean currents don't actually add thermal energy to the planet. All they do is move the energy around, sort of here. Okay, so I think I might be getting.
Oh, yeah,
Let
I
me
don't wanna
continue a couple more
sidetrack you, but,
slides,
yeah,
and
there's
that point
biological
of-
effects of things that will happen, I think,
Yeah.
long before
Okay.
all the ice melts.
Oh, absolutely, absolutely. But
Okay.
what I'm trying to drive home here is that we're going to render ourselves in a very, very untenable situation a lot sooner than is what being characterized in the mainstream media. It tends to get pushed off to, well, it's someday, you know,
Oh,
or what is
okay.
catastrophic. Right. So this is just looking at one simple variable, okay?
Mhm.
Total energy to melt all the ice. Now we'll see that when we do that, the surface temperature is going to increase a lot. And we'll
Oh,
talk about that
okay.
too. Okay, so there are huge biologic effects which are being seen all over the place. That's true.